Hello, my name is Dylan Cope. I'm the first author on this paper, joining the conversation toward language acquisition for ad hoc team play. So quickly, ad hoc team play is the situation in which agents have to coordinate on a task with other agents that they've never met before. And these agents are assumed to be sampled from some pool of agents where they have collaborated with other agents in the past successfully. So the situation we're going to be looking at specifically involves ad hoc team players that are competent within these teams by virtue of a shared language, i.e. they can talk with one another. And our task is going to be to build another agent that can join in on this conversation and also collaborate in an ad hoc team fashion with the agents in that pool. So think of this as a community of language users, and you want to learn their language in order to work with them. So the way we're going to do this is to break it down into two problems. And we're going to collect some data about the agents that are interacting in the community. We're going to look at messages that were sent and things that listeners did as a result of those messages. And we're going to learn to emulate the speakers in terms of producing messages that cause certain behaviors, and emulating the listeners in the sense of interpreting the messages of speakers and producing those behaviors ourselves. So that's the forward problem. The forward problem is going to be signaling. It's going to be, how am I going to produce these messages? And this is going to be relatively easy from the data we have available to us, because we can just apply supervised learning. We have messages, we have behaviors in the form of trajectories that were taken, and we can just learn the mapping between the two. So if we want a behavior to occur, we can just find the message that would most likely induce that behavior. However, the backward problem, the idea of listening, is not straightforward. And the reason is because when we have data about communication interactions that have happened in the past, we only see what the listening agent did as a result of hearing the message. We don't directly observe ever the intended behavior that the speaker wanted to induce in the listener. That is hidden within the mind of the speaking agent. So how we solve this is by making some assumptions about the speaking agent. Namely, we make the assumption of Boltzmann rationality, which is the idea that the speaking agent might not be perfect at getting the listening agent to do a certain behavior, but they may be relatively good, and they will also select behaviors for the listeners to do that maximize the reward of the shared task. And that's the basic idea that we employ in producing the agents, and we sort of devise a probabilistic formulation and work out a loss function for training both sides of this. So that's the basic idea of this paper, and I look forward to seeing you at the ICLR discussion group. Thank you very much.